Good afternoon, everyone. In today's video lecture, we'll see how to perform F-test. Before performing an independent two-sample t-test to compare the mean drug dissolution of two formulations, an F-test is performed to determine whether the two groups have equal variances. So here we will see here we will see whether drug A and B have equal variances. So drug A, this result shows the percent dissolution of drug A and percent dissolution of drug B. Okay, actually we are going to perform an independent two sample t-test, but before undergoing the two sample t-test, we need to check whether they have equal variances or unequal variances. Actually, F-test will help us in this regard. Okay, because without knowing whether they have equal variances or unequal variances, you cannot perform the t-test, as I have shown in my t-test video or pair t-test video in my channel. So it's important to see whether they have equal or unequal variances. Okay, so to do this, first of all, come into file, then option, then add-ins, then click on go. Now you have to add analysis tool pack to do this study. So click on here and click on OK. So after that, in the data, you will find data analysis. Yes, here is the data analysis. Whenever you will click on the analysis tool pack, you'll find this value. Now, as we are going to see the variances, the difference of their variances, first of all, let's check their variances. Okay, you can see the variances of A and B. One of them is 4, one of them is 6. But you cannot conclude whether they are equal or unequal, because you have to perform this by utilizing some p-value. Okay, so to do the test, click on the data analysis. Okay, then you can see F-test two sample for variance. Click on F-test two sample for variance, then click on OK, because we are going to do F-test. Okay, for two sample for variance. Okay, so click on OK. Now variable 1 range and variable 2 range. For variable 1 range, click from drag A to here. For variable 2 range, click on drag B to 84. Okay, then level. Yes, my level is 0.05. Sometimes it can be 0.01. Okay, but uh, 0.05 alpha is 0.05 by default. Now how you want your output? I want my output as new worksheet. Okay, so click on OK. Now you can see your result. Here is the F test two sample for variance. Mean is 85. Here drug B mean is 81. The variance is 4, variance is 6 that we have calculated. The observation is 8. Here observation is 8, we have seen. Then degree of freedom. Okay, so degree of freedom, how would you calculate it? Total number of sample minus 1 is equal to degree of freedom. So n minus 1. Okay, n minus 1 is the degree of freedom, as we know. Then F test, we can see the value of F. We can also see the value of our p value 1 tail, and here is the F critical 1 tail. Okay, so our F value is higher than the critical one. Here you can see the F value is 0.66. Actually you can do that, you can calculate that by comparing the variance. Just click on equal to, click on the first variance, divided by, click on the second variance, actually you will get the value. Yes, here is the f value. Okay, here is the f value that is equal. You can also do that manual. And another one is critical value, that is 0.26. Actually this is calculated by excel utilizing your alpha value, that is 0.05, and utilizing your differences of variance. Okay, so we need this p value. So what is our p value? We can see here it is zero point 0.3. Okay, so which is higher than 0.05. Actually what does it mean? So p value zero point 0.3 means it is higher than what? It is higher than 0.05. That means we proceed to perform the t-test and assume that a and b have equal variances. Okay, so it is greater than 0.05 means our drug a and drug b variances, dissolution variances, are equal. Okay, so this is our strength. So how it has been calculated? So our null hypothesis, null means zero, zero means zero difference, zero means zero. Okay, so there is no difference, okay, between the variance of a and b drug dissolution. Okay, so this is our null hypothesis. So this is not, we can say the variances are equal because null means zero, zero means zero differences. Then alternative hypothesis, as it is one tilt, that means drug A has higher variances in dissolution compared to drug B. So alternative means A will have higher variance than B, but our p value is higher than 0 0.05, so they have equal variances.